In this chapter, you'll learn about tag-along. Tag-along is what we use to have holograms follow us around the room at a relatively fixed distance. In the Project panel, find the Scripts folder. There, you'll find the Gesture Manager. Click on the Manager object in the hierarchy, and then drag and drop the Gesture Manager from the Project panel into the Inspector panel. Double-click to open the Gesture Manager in Visual Studio. Now, this isn't a gesture course, so we're not going to dive into this too deeply. All we'll do is give you a simple select gesture. So what we'll do is create a new gesture recognizer and subscribe to the tap event. When a tapped event is detected, we'll find the currently focused game object, and that's the hologram that the user is looking at. Then we'll send that hologram a message on select, and the hologram can decide what to do based on when they get that on select message. Now we'll add tag-along to our project. So head back to Unity and select the Holo Toolkit folder. Go into the Gaze subdirectory, and there you'll find the simple tag-along script. We're not going to assign it to anything quite yet. Just double-click to open it in Visual Studio. We have a few public parameters that are of interest to us. The first is tag-along distance, and this is the distance in meters away from the camera where we're going to put our hologram as it follows us around the room. And next, we have this enforce distance parameter, and if true, we'll force the tag-along to respect that distance from the camera. The next three parameters, which we won't dive into, dictate the speed and motion of how that tag-along follows you. You can play with these values in Unity later. In the fixed update function, we'll first grab the frustum planes of the camera. Then we'll determine if the tag-along needs to move based on whether it's in the camera's view or outside of it. If it's outside the camera's view, then we need to calculate a new position for that hologram. And we'll do that in the Calculate Tag-along Target Position function. Let's head down to that function. The first thing we'll do is determine if we need to move, and we'll do that by testing if our hologram is within the camera's frustum planes. In the diagram, the two blue lines represent the camera's view frustum, and position 0 represents our hologram. As you can see, it's outside of our camera's view, so we need to move it. Next, we're going to calculate a default position where that hologram should go. And in our case, it's just 2 meters out from where the user's looking. And we'll represent that on the diagram as position number 1. So if we determine we don't need to move our hologram, we're just going to bail out of this function. We're done. But if we do need to move, we need to do a little more math. We're going to create an array and set its origin to be that default position that we just calculated, position number 1 in the diagram. We don't yet know what direction to cast that ray in, but we'll calculate that next. Now we need to determine if the hologram needs to move to the left, to the right, up or down to be within our view frustum. For our hologram, it's to the right, so we need to move it to the left. We determine that by calculating the distance from the right frustum plane to our hologram. If it's less than 0, then we need to move. All right, because we need to move left, we'll set the plane variable to the right frustum plane, and then we'll cast our ray to the right. In the diagram, you'll see we're casting a ray from position 1, and where it intersects with the right camera frustum plane, that's position number 2. Because our hologram needs to move in the X direction, we're going to cast a ray from the default position to the plane we're working with, which is our right frustum plane. Then we'll get the point along that ray that is on the plane and update the X component of the tag-along's desired position. Next, we'll create a ray that starts at the camera and points in the direction of the calculated to position. Then we'll find the point along that ray that is the right distance away from our calculated position to be that point. On the diagram, that's point number 3. And point number 3 is the 2 meters out that we wanted for our tag along. And now we're done. So we return the needs to move variable, which should be true, and then the update function will handle moving that position smoothly and quickly. Now we'll open the interactable script. If you don't already have it open, in Visual Studio you can go to the right-hand side, expand the Assets folder under the Assembly C# project, open up the Scripts folder, and then open up Interactable. Now you can take a minute and fill out coding exercise 6A, or you can use the completed solution in our documentation. We're going to scroll down to the bottom to the onSelect function, and there we'll just add one line of code. And what that does is send a message to the interactable object to perform tag along, and that means it will start following you around the room. Now we need to go back to Unity. In the Holograms folder, click the Tag Along asset. In the inspector, at the top, you'll find a tag drop-down. Click on that drop-down and select Add Tag. Select the plus sign in the tags list. Rename the new tag to be Tag Along. Go back to the Holograms folder and select the Tag Along object again. Find the tag drop-down once more, select it, and change the tag to Tag Along. Now head back to Visual Studio. On the right-hand side, expand the Scripts folder and find Interactable Action. Double-click to open it up. This script receives the Perform Tag Along message. First we'll check, is our object to tag along null? And if it is, we're just going to bail out. We recommend only having one tag along in your scene, so if there's already one there, we're just going to return. Next, we'll create an instance of the object to tag along, and we'll set it to active. Now you're welcome to follow along coding exercise 6B, or use the existing solution we have in the documentation. What I'll do is just paste this in. What we did was we added the billboard component to the instantiated object to tag along, so our hologram is always facing towards us. Then we added simple tag along, so it's always following us as we move around the room. Now you're ready to go back to Unity and deploy as usual. Congratulations! You just completed Holograms 210, our gaze tutorial. You learned about cursor and target feedback, the directional indicator, billboarding, and tag along. And we're excited to see what you can build.